Bite of Truth. Why your toaster needs a security clearance. Eyes European paradox.
Hello and welcome to Bite of Truth, the podcast that cuts through the hype to get to the heart of what's really happening with AI. I'm your host, Sebastian. Let's start with a thought. What if your toaster, yes, your humble breakfast appliance, needed a top-level security clearance to operate? It sounds absurd, right? But this week, we're seeing how the little cracks in AI security are turning into canyons, and it's making us question everything we thought we knew about safety. Researchers at a major AI conference found that even with new defenses, they could still trick advanced AI systems in about 8% of attempts. 8% doesn't sound like much, but would you get on a plane if there was an 8% chance of its controls being hijacked? Suddenly, that toaster doesn't seem so silly. This is the European paradox playing out in real time. On one hand, you have groundbreaking work, like an AI that can design new drugs or even smooth out traffic jams to save fuel. On the other, we have fundamental vulnerabilities that could let someone or something take the wheel. It's a race between incredible promise and profound peril. So today, we're diving deep. We'll unpack the math that finally demystifies how language models learn words, explore the coming war between your favorite apps and AI agents, see how AI is turning from a diagnostic tool into a drug inventor, and ask, what happens when we finally build an AI that never forgets? All that and more, coming up on Bite of Truth.
Research Deep Dive. Math that matters.
So, for years, we've called large language models a black box. We put data in one end, and coherent, sometimes even brilliant, text comes out the other. But how it happens has been a bit of a mystery. We knew it worked, but the why was buried under trillions of parameters. Well, this week, the box got a little more transparent. The big story is about a model you might know, Word2Vec. It's one of the foundational technologies that helped kickstart the entire deep learning revolution in language. And a new paper provides the first ever closed-form theory, explaining exactly what it learns. Think of it like this. Word2Vec turns words into numbers, or vectors, in a high-dimensional space. For years, we just knew that words with similar meanings, like king and queen, or walking and running, ended up close together. The new theory, from researchers including Dhruva Karkata, shows that this process is essentially just principal component analysis, or PCA, in disguise.
That's a classic, century-old statistical technique.
This isn't just some academic footnotes. It's a roadmap. By understanding the fundamental math, we can build models that are more efficient, more predictable, and less of a gamble. And speaking of new paradigms, let's talk about reinforcement learning, or RL. This is the method that teaches AI through trial and error, like a video game character getting points for good moves. The backbone of RL for decades has been something called temporal difference, or TD, learning. It's how an AI learns to connect a future reward like winning a game with an action it took many steps earlier. But for long, complex tasks, TD learning can struggle. So researchers threw it out. A new method divides and conquers. It breaks down a massive, long-horizon task like a robot, learning to assemble a car into smaller, manageable sub-goals. This approach, getting rid of TD learning entirely, is proving to be far more scalable and effective. It's like solving 1,000 tiny puzzles instead of one impossibly large one. It's a quiet but fundamental shift in how we teach machines.
Corporate moves and industry shifts.
All right, let's shift from the research lab to the boardroom, because all this math is powering a very real and very messy fight for the future of your digital life. The question is no longer just, what can AI do, but who gets to own the interface to it? And at the heart of this is the battle between apps and agents. For years, the app has been king. You have a problem. You download an app. You want to order food. You open DoorDash. Do you want to listen to music? You open Spotify. But the new wave is AI agents. Imagine you just tell your phone, I'm hungry for Thai food, but I'm trying to save money. and a single AI agent goes and finds the best deal, places the order, and puts it on your calendar. That's the threat developers are facing. Has a new article titled, "AI Devices Are Coming. Will Your Favorite Apps Be Along for the Ride?" points out. Developers are starting to resist this. Why build a beautiful, feature-rich app if a generic AI agent is just going to stand between you and your user? It's a battle for control. Do we live in a world of specialized, curated destinations, or one central conversational hub that does everything? And this isn't just theoretical. We saw it in academia. At STOC 26, that's the Symposium on Theory of Computing, Google's Gemini, was used to provide automated feedback for peer-reviewed theoretical computer science papers. Let that sink in. An AI is now acting as a peer reviewer for some of the densest, most complex research in the world. It's a massive leap for academic rigor, but it also signals a huge shift. If AI can vet cutting-edge research, what part of the knowledge economy isn't it about to disrupt? Okay, let's circle back to that toaster and its security clearance. The reason we're even having this conversation is because AI's security is, to put it mildly, a bit of a mess. And the biggest headache is a threat called prompt injection. This is when someone tricks an AI into ignoring its own instructions and doing something it's not supposed to. The Open Worldwide Application Security Project, or OWASP, lists this as the number one threat to LLM applications. But here's the thing. A lot of the safety claims we've been hearing might be bogus. A new paper titled How to Evaluate Jailbreak Methods, a case study with strong R-reject, exposed the problem. It turns out that many studies claiming to jailbreak a model with a 90% success rate were using methods that looked good on paper but failed basic usability tests. The prompts were so convoluted or nonsensical that a human wouldn't even use them. The real-world success rate for many of these attacks is much, much lower. It's a reality check. We need better ways to measure what's actually a threat, not just what sounds scary. On the bright side, there are people building the locks. New defenses, called Strook and Sec-Align, are showing real promise. They work by structuring the prompts and aligning the model's core programming to resist these malicious instructions. In tests, they were able to slash the success rate of a major type of prompt injection attack from 45% down to just 8%. That's a massive improvement. But that brings us back to our provocative question. If we can still get through 8% of the time, is any system that relies on an LLM truly safe? The answer, for now, is probably no. And that's a truth bite we all need to swallow. All right, let's talk tools. Not hammers and screwdrivers, but the new architectures and systems that are quietly reshaping what AI can do. And they're solving some of its most fundamental problems. First up, amnesia. Large language models have terrible long-term memory. They're like a goldfish that just finished reading the entire internet. They can tell you about the fall of the Roman Empire, but they'll forget what you asked them 5 minutes ago in a long conversation. It's called context window overflow, and it's a huge bottleneck. A new framework called Titans, paired with something called Miras, is changing that. Think of it as a compressed memory system for AI. It allows a model to store the essence of a long conversation, not the raw text, and recall it later. This is the breakthrough that makes an AI that actually remembers possible. Instead of just being a reactive tool, it can start to become a proactive partner that builds on past interactions. Then there's the push for efficiency. We hear a lot about bigger and bigger models, requiring more and more data centers. But what if we could make small models smarter? A system called Disciple allows smaller language models to collaborate and self-steer to solve complex tasks. They pool their knowledge and delegate work. It's like a team of clever interns who can figure out how to build a skyscraper without needing a superstar architect for every little detail. This is a win for sustainable AI, making it smarter, not just bigger. These tools aren't just academic curiosities. They are the foundational building blocks for the next generation of AI. An AI with a real memory. An AI that can run efficiently on your phone without calling home to the cloud every 2 seconds. This is where the real, transformative change is happening below the headline-grabbing product launches. So, let's tie it all together. This week, we've seen AI's stunning double-edged sword. On one edge, you have raw, world-changing potential, the math behind words being decoded, algorithms that can ease traffic jams and reduce our fuel consumption by 20%, and protein models that are now moonlighting as drug designers creating brand new molecules to fight disease. On the other edge, you have the flaws, the vulnerabilities that allow an attacker to slip past the firewall, the oops moments that remind us we're building on fragile foundations, and the existential question for developers: if an AI agent can do it all, why does your app even exist? We live in a time of incredible paradox. We are simultaneously achieving some of the most elegant and powerful technological feats in human history, while wrestling with problems that feel surprisingly basic. It's like we've built a starship but can't figure out how to lock the cockpit door. The European story is a microcosm of this global tension. The drive to innovate, to push the boundaries of what's possible, collides with the need to regulate, to protect, to make sure that our smart toasters don't develop a taste for chaos. The march of progress is inevitable, but the path it takes is ours to choose. The future of AI won't be defined by its capabilities alone, but by our collective wisdom in guiding them. That's all for this edition of Bite of Truth. You can find links to all the research and articles we discussed today in our show notes. Thanks for listening. I'm Sebastian.